Basics: Variable declaration, built-in types, and constants. In this video, we're going to introduce some basic concepts in Go that we will use throughout this course. We'll start out by looking into variable and constant declarations, and we'll move on to study Go's built-in types. We'll take a look at several Go program examples to help you get acquainted to these essential concepts. We'll end the video with an example showing how to use Go's iota enumerator. So how do we declare variables in Go? In the first example we have here, to declare a variable, we use the var keyword, followed by the identifier, followed by the type. Moving on to the second example, in addition to declaring a variable, we can also initialize it with a value. The value is known as the initial value of the variable. Finally, in the third example, the := operator is a shorthand notation that we use for both declaring a variable and initializing a variable. Even though we haven't stated the type of the variable, Go figures out what type the variable is. The zero value. Variables that are declared without an initial value are given their zero value. Every type in Go has a zero value. For numeric types, the zero value is 0. Now, let's take a look at multiple variable declarations. Go also provides us the capability to perform multiple variable declarations in one statement. In the first example, we declare 3 variables of the same type. Note that we only need to include the type once at the end. In the second example, we declare 3 variables of the same type and initialize all 3 of the variables with a value. Variable name1 is assigned the value of value 1, and so on. In the third example, we use the := operator to declare and initialize the 3 variables. Declaring a constant. When we want to declare a constant in Go, we use the const keyword before the identifier. Once we have declared a constant, its value cannot be changed for the life of the program. Now that we know how to declare variables and constants in Go, let's take a look at Go's built-in types. Let's start with the Boolean type. Booleans are used to represent the truth of something. They can hold a value of either true or false. The zero value of the Boolean type is false. We can model a simple light switch using the Boolean type. A simple light switch can have one of 2 states. It can either be turned on, which we can consider as true, or it could be turned off, which we could consider as false. Opening up the example lightswitch.go, in the lightswitch directory, we declare the variable lightSwitchIsOn, which is a Boolean that tells us whether the light switch is on or off. Besides our usual main function, we have 2 functions in this example. The first is called printLightSwitchState. This function is responsible for printing the current state of the light switch. The second function is called toggleLightSwitch. This function is responsible for toggling the value of the light switch. For instance, if the light switch was off and we called the function, the light switch would be turned on. And if the light switch was turned on and we called the function again, it would be turned off. Inside the toggleLightSwitch function, we use the ! operator to give us the inverse value of the lightSwitchIsOn value, and we assign that value to the lightSwitchIsOn variable. Our main function simply prints the states of our light switch as we toggle it 2 times. The numeric types in Go consists of integer, floating point, and complex types. Here's a table containing all of the integer types. We use the family of uint types to declare unsigned integer values. We use the family of int types to declare signed integer values. You would have noticed that most of the numeric types we have listed here have a number right behind the type. The number signifies the bit size of the type. For instance, an int 64 can hold a 64-bit integer value. There are two types here that we don't have numbers following them, the int type and the uint type. The length of the int and uint types equals the processor bit size. So, if you have a 64-bit processor, int will have a length of 64 bits. Floating point numbers. Floating point types are used to represent numbers that contain a decimal point. Here's a table containing all of the floating point types in Go. Complex numbers. We can use the complex 64 and complex 128 to represent complex numbers. Let's take a look at the declarnumerics.go source file in the declarnumerics directory. We start out by declaring a 32-bit integer without initializing it. Remember that variables declared without an explicit initial value are given their 0 value. We expect to see a value of 0 here since the 0 value of an int32 type is 0. Next, we declare and initialize two float 64s and then show their sum. Below that, we have an example of an assignment where we use the := operator to declare and initialize variables x, y, and z. Moving on, we have an example where we declare and initialize a complex number with a real and imaginary part. Finally, we show an example of how we can group constant and variable declarations. We can write out the type and then include a parentheses, and the variables can be declared and initialized within the parentheses. Note that when we declare variable a, we have declared its type. This is optional and not required. If we don't specify the type, for example, for variables b and c, Go will figure out the type by itself. In this case, Go knows that b is a complex number and c is a floating point number. Grouping imports. Besides grouping constant and variable declarations, we can also group import statements. We use the import statement to tell Go which package we want to include in a program. In this example, we have imported the formatting and OS packages. We will be learning more about packages in the next video. In Go, we use the string type to represent strings. Strings in Go are in UTF-8 format, and they are enclosed between two double quotes. A string can be considered as a sequence of letters. Strings in Go follow zero-based numbering. If we examine this string, gopher, the element at index 0 is the letter G. The element at index 5 is the letter R. The 0 value of the string type is an empty string. In Go, we use the plus operator to concatenate two strings. Let's take a look at the stringbasics.go source file. In the stringbasics directory, we declare the string variable subject and assign it the value of gopher. We first print out the letter at index 0 of the literal string value gopher, which is G. Next, we print out the letters at the first and last index of the subject variable, which is G and R. Finally, we show an example of using the plus sign operator to concatenate the string hello with the subject variable, and again, we concatenate that to the exclamation point. Here's what we get when we run our example. Now that we have explored Go's built-in types, let's look at one of Go's awesome features, the IOTA constant generator. We can use Go's IOTA constant generator to represent enumerated lists. For example, the three possible states of a traffic light are red, green, and yellow. These can be modeled by an enumerated list of numbers. The number 0 is a don't care value. The number 1 indicates the red light. The number 2 indicates the green light. And the number 3 indicates the yellow light. Let's open the trafficlights.go source file. We start out with a constant grouping declaration to declare the multiple traffic light states. In the first constant declaration, notice that we assign the value of iota to the identifier named underscore. The underscore character in Go is called the blank identifier. We assign a value that we don't care about to it. It's a more elegant way of indicating that we want to discard a value without having to declare a dummy variable. The iota enumerator allows us to build sets of values. For example, in the first declaration, the value of iota is 0. In the second declaration, the value of iota is 1, then 2, and then 3. We print out values of the various traffic light states, and note that the values for the traffic light states match the states that we have defined in the illustration. Let's take a look at a more sophisticated example where we use the iota constant generator to model the year the Summer Olympics took place at a particular city. We'll start from the year 1984, where the Olympics took place in my hometown. Let's open up the Olympics LA Onwards.go source file. In the Olympics LA Onwards directory, in our constants declaration grouping, we start out by defining the value of Los Angeles to be 1984 plus iota times 4. In the first case, iota is 0, so the value of the expression in parentheses will be 0, and the year that the Olympics took place in LA will be set to 1984. In the second case, the value of iota will be 1. 1 times 4 is 4, and we will be adding 4 to 1984, giving us 1988, which is when the Olympics took place in Seoul. Similarly, in the third case, the value of iota will be 2. 2 times 4 is 8. Adding 8 to 1984 gives us 1992, which is when the Olympics took place in Barcelona. And we continue with the other cities where the Olympics took place, and in 2020, the Olympics is expected to be held in Tokyo. We select 3 cities from the list and printed out the dates. Let's run the program and inspect their values. If we check the city with the year, we will note that we have properly assigned the year the Olympics took place at that particular city. As a homework assignment, try to model the years and cities when the Winter Olympics took place. In this video, we covered how to declare variables and constants in Go and examined Go's built-in types. We also saw an interesting example of using Go's iota constant generator to model the year the Summer Olympics took place at a particular city.